The spectral signature is a graph where we compare the wavelengths with the reflectance of the radiation. And you see that this radiation change along the reflection of the radiation change with the wavelength. Here in the right there are three spectral signature, one of soil, one of green vegetation and one of water. So it's very important that to focus on this part that is the infrared, the near infrared radiation, where we see that water and green vegetation have a different spectral signature here in the infrared, around 0.8 micron. And here you see the spectral signature of different objects: snow and ice, clouds, dry soil, wet soil, turbid water or clear water. This is very, very important, as we can recognize from satellite image the presence of this object on the surface, and we can extract information of this object. Vegetation spectral signature is related to different information from different characteristics of the vegetation. That is the possibility, the capacity to reflect light, and we see that the reflection of green light, it's very clear, but a very, very important part of the absorbed and reflected information is in the near infrared, where near infrared is characteristic of the interaction with the structure, the internal structure of the leaves, the vegetated leaves. And here you see the optical mechanism of vegetation. So we have the surface of the leaf that is reflected in the green, and we see green. The cell structure is reflected from the near infrared, and the water absorption is absorbed in the shortwave infrared. So to analyze the state of the health of vegetation, we can analyze visible, near infrared and shortwave infrared related to different characteristics. So if we want to analyze the water content of vegetation, we have to use data from shortwave infrared. And here you see the behavior of different kind of vegetation, as grass, fir tree or dry yellow grass, that is completely different in the spectral signature. Vegetation and soil, this is very important because we have to compare the spectral signature of vegetation and spectral signature of soil. You see the behavior of green vegetation and dry vegetation, and you see that the spectral signature in the infrared part of the spectrum is completely different. We have a low reflectance for dry vegetation, and this reflectance, this behavior can be compared with soil, and sometimes the spectral signature is very similar. But in particular, the optical mechanism of soil is represented here in this graph, where we see the different reflectance of soil with different content of water. Okay, where the soil is dry, the reflectant is high, and where the soil is wet, the reflectant is low, with some bands of absorption around medium infrared, around 1.5 and 1.9 medium infrared. And here you see the differences between a sandy soil and a silty soil with different water content. So it's possible to analyze the different soils with different water content, and for us will be very important in our application. Last spectral signature is dedicated to the water. So water have a different behavior along the spectral, along the wavelength, and we see that clear water have a reflectance in blue and an absorption in the near infrared, as the turbid water, where there are sediment or other kind of sediment turbidity, we have a reflectance in the infrared. So it's very important to analyze the water quality. When we compare the spectra from vegetation and water, we can see that there are a very, very important behavior, different of behavior here. And here we see in the medium infrared, the water has a reflection and the vegetation has an absorption. That means that we can divide these two information from the satellite data. Last topic of this lecture is dedicated with a brief discussion of time series, because it's very important to compare the behavior of the object during the time. Here we see a land cover change. This is a very well-known image. This is the Lake Chad from 1972. This was the first satellite image, a Landsat satellite image, and here on the right you see the same geographic site acquired in 2001, and we see that almost all the lake is disappeared. There are only some wet areas. So it's very important to analyze many images to understand the land dynamic. In particular, time series can be used to test our understanding, and the time series can be composed of real data. So we will see that we will use spectral indexes to analyze the dynamics of the crops of the environment. And in lecture 3, we will we will graph the indexes to analyze the irrigation, the change of irrigation. Here you see two examples of time series composed by NDVI profiles of crops in Kansas. And you see that there is a regular acquisition of data. So along the year, we can analyze how this vegetation is, how is the dynamic and health of the vegetation during an year. Thank you.